Hello friends, welcome to engineering tutorial. So in the previous few videos related to the basic concepts of electricity, we discussed about the elementary particles, some basic concepts associated with them, uh, basic concepts about electric charge, the introductory concepts. So in this video we are going to take our discussion forward and we'll discuss about electric field. Okay, some basic concepts associated with electric field. Okay, so in order to understand electric field, first let us consider a situation in which we have a large positive charge denoted by capital Q, and we have a small positive charge which we will call as test charge, okay, which is placed near it. Now as both these charges are positive, so naturally this large positive charge will exert a repulsive force, a force of repulsion on this small test charge, positive test charge, and try to push it away from itself. Okay, so let that force of repulsion be denoted as F subscript E, okay, electric force of repulsion. Now, from this electric force of repulsion and this test charge, we will determine the electric field intensity. Okay, so here is the concept of electric field. So, the electric field at any point in space, okay, it is defined as the electric force acting on a positive test charge, okay, divided by the test charge itself. Okay, so the electric field is expressed as the ratio between the electric force exerted on the test charge divided by the test charge itself, F subscript E by Q0. So here this electric field intensity is the electric field of this large positive charge capital Q. Okay, the electric field of this large positive charge Q, okay, the intensity is given by the force which is exerted, the repulsive force which is exerted by this large positive charge divided by this test charge, the small test charge Q0 itself. Okay, the force which it exerts on this positive test charge divided by the test charge itself. Okay, Fe by Q0. Okay, so here both the positive test charge and the electric force of repulsion, they come into play. Okay, so we know that electric force is a vector. Similar to that, the electric field is also a vector quantity. It has both magnitude and direction. We need both these things to define an electric field. So in vector form, this equation, which is in scalar form, it will be transformed to this type. Okay, E vector, electric field vector, is equal to force vector divided by the charge Q0. This is the electric force of repulsion exerted by this large positive charge on this small positive test charge divided by the test charge itself. Okay, so this is the concept of electric field and its mathematical representation. Okay, so now let us try to express electric field in terms of Coulomb's law. Okay, we have already discussed about Coulomb's law, which is the mathematical representation, okay, which gives us the mathematical representation of the electric force, whether it is attraction or repulsion between two charges separated by a certain distance. So let's say if this large positive charge and this small positive test charge, they are separated by a distance r. So the mathematical representation of this electric force of repulsion as per Coulomb's law is this. Okay, it is directly proportional to the product of the charge and inversely proportional to the square of the separation between them, that is k capital Q multiplied with small positive test charge Q0 by R square. K is the Coulomb's constant and this is the electric force of repulsion. So electric field is Fe by divided by Q0. So Q0 got cancelled out. So the electric field is kq by r square. This is the expression of electric field in terms of Coulomb's law. Okay, the test charge got divided. Okay, so that's why Q0 got cancelled out and E is equal to K capital Q by R square. Now in vector form, just this vector sign comes above the E, so it becomes E vector is equal to kq by r square r cap, where r cap is the unit vector. Okay, so I recommend you to please watch the Coulomb's law video also, so that you understand these things in a better way. Now we have always tried to correlate the concept of electric field with gravitational field and to find out some similar points, some analogous relationships between the two. So here also we'll try to do that. We'll try to correlate the concept of electric field with gravitational field. Okay, try to find out some analogous relationships. So we know that the gravitational force of attraction between any two objects, let's say they have masses capital M and small m, so the gravitational force of attraction between them will be given by Fg is equal to G m multiplied with m, capital M and small m, divided by r square. Okay, G is the gravitational constant, universal gravitational constant. So here also the gravitational force is directly proportional to the product of the masses and inversely proportional to the square of the separation between them. Much similar this equation to the Coulomb's law equation. So also the gravitational force experienced by an object in space is given by Fg is equal to mg, where m is the mass of the object and g is acceleration due to gravity, which is generally taken as 9.8 meter per second square. So the acceleration due to gravity g, if we try to find out the value, if we take m towards the left hand side, will become g is equal to Fg by m. Okay, the gravitational field, the acceleration due to gravity, which we will call as the gravitational field, is given by G is equal to Fg by m. So now you try to compare this equation G is equal to Fg by m with this equation E is equal to Fe by Q0. So here you will find some analogous relationship. So here the electric field E is analogous to the acceleration due to gravity small g. The electric force of repulsion Fe, okay, is similar to the gravitational force of attraction Fg, and the charge, the test charge present in the electric field vicinity is analogous to this small object or any object of mass m. So again, as I already told to you in the first video of this course, that charge, mass, they have analogous relationships. That is, mass in mechanics plays the same role as charge in electricity. So this analogous relationship, these two equations, by comparing this equation with this, okay, we will just identify those analogous relationships. Okay, trying to correlate electric field with gravitational field. Okay, so here we have discussed some basic concepts related to electric field. Okay, its basic definition and the mathematical representation in both scalar and vector form, and also we expressed electric field in terms of Coulomb's law and established a correlation there, some trying to find some analogous relationship between electric and gravitational field. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.